Hello, Keystone students. Yesterday we started talking about correlation and about lines of best fit, and just kind of giving you a brief little overview. Today we're going to try to get into the nitty gritty of how do we actually write the equation of a line of best fit. It really revolves around picking 2 points and using y equals mx plus b, which I hope that you already did the warm-up activity, and we're also able to check your answers. So the first thing, there's a couple of different ways that we can be given information. Best case scenario, they are going to give us both our slope and our y-intercept, right? That's the easiest way, because then it's just a matter of plugging into y equals mx plus b. Another option is that they can give us the slope and a point, which isn't too bad. The only thing there, we have to find b, and then worst case scenario is when that we are given 2 points, and that's going to take the most amount of work, because then we have to find first our slope, and then second we're going to find our b. Okay, so again, first find the slope, and then second find the y-intercept, which is our b. So why do we use line of best fits, or what's the purpose of line of best fits? So if you have noticed what we talked about yesterday, all of those things are scatter plots, right? They're actual data that we put on a chart to look at the trends. And the number one reason that we use a line of best fit is that we want to be able to make a prediction about what's going to happen, right? Just because our actual data, we can kind of get an idea of what it's going to look at, but we can't really use those data points to make predictions, because there could be multiple things happening at one given point. So our line of best fit is going to allow us to make a prediction. So we want to make a line that follows the trend of all of our data points, right? As they're moving up, we want our line to be moving up, or as they're moving down, we want our line to be moving down. We want roughly half of the points to be above, and we want roughly half of the points to be below our given line. Lastly, we want to, if possible, to make our lives easier, try to have our line go through 2 of the data points that we have. This will make it a little bit easier for us when we go to write the equation of a line. We don't have to guesstimate. So the one thing to remember is that there's going to be tons of line of best fits. And there is one that is the best line of best fit. However, that takes some higher level mathematics. So we're just going to be eyeballing it. So we talked yesterday about correlation, right? We can have positive correlation, which means that our line is going up. We can have negative correlation, which means that our data points are going down. And we can have no correlation. It's almost like someone just completely randomly put dots on a board or threw spaghetti against the wall and see where it's stuck. The closer to a straight line, the higher our correlation is going to be, right? So a correlation of 1 or -1 would mean that the dots lie in a perfectly straight line. We can calculate the correlation coefficient, but that's something, if you're interested in, I would recommend that you take statistics down the road, because you'll be actually calculating those 2 points. Okay, so let's look at our first example. The graph below shows heights and shoe sizes of 20 girls. So this kind of makes sense, because as a person is taller, we would expect them to have a bigger shoe size. So that means our correlation is positive. And how that helps us is it really means that if we have a positive correlation, our slope should then be positive when we go and figure it out. So we're going to pick 2 points. So the points that I'm going to pick are 54,6, and I'm going to pick 62,8. Those are nice points that they go through, and I'm going to draw a line connecting those points, and that's going to be our line of best fit. If you notice, we have roughly half our points above this line and half our points below this line, and for the most part, it follows the trend of the data. It is important here to know that not all of the lines are going to be exactly the same. Okay, so now we have 2 points. We have 54,6, and we have 62,8. 8. So we're going to find the equation for the line between those 2 points. So we're going to find our slope 8 minus 6 y2 minus y1 over 62 minus 54, which is going to give us 2 over 8, which is 1/4. And for line of best fits, it's usually typically best to use decimals, just because it's going to make our life a lot easier. Now we pick one of those 2 points, so I'm going to use 62 and 8, so I'll do 8 equals 0.25, right? I'm just plugging in to y equals mx plus b. So 8 equals 0.25 times 62 plus b. So 8 equals 15.5 plus b. So b equals negative 7.5. So our equation is y equals 0.25x minus 7.5. So this then would be what we would use to make predictions about what's going to happen in the future.